To deal with the demanding launch, cruise, and landing environment, our space instrument needs to withstand shock, vibrations, and impact during the long journey. And we need to deal with the mechanical and electrical shock on landing, and extreme lunar environment of drastic temperature range, high radiation, high vacuum, and 1/6 gravity. Our system has been successfully deployed on the near side and far side of the Moon respectively. It was installed on top of both the Chang'e 3 and 4 lunar lander to facilitate panoramic image capturing and rover movement on the Moon, and helps construct a precision 3D model of the surrounding landscape for safe rovering. It can rotate 350 degrees and pitch 120 degrees at high position accuracy within a large operating temperature range from -40 degrees Celsius to +80 degrees Celsius and survive the low storage temperature of the lunar night, which can be as low as -180 degrees Celsius. There are several innovations in our system. Firstly, it was bolted onto a special locking and damping mechanism to protect the camera as well as the sensitive precision motion parts from shock and vibration during launch, transfer, and landing. Secondly, multi-angular absorptive and refractive surfaces were used for effective thermal control. Thirdly, it has internal through channels for secure cable protection and management inside the moving axis. Fourthly, it was designed with integrated motion mechanisms, structural members, and external frameworks for high rigidity and weight reduction. These innovative features make our system compact, lightweight, precise, and of high stiffness. Compared to other solutions, our system is the world's first of its kind deployed on the far side of the Moon. Moreover, it has much lighter, more compact, more power saving, with unique vibration damping and secure cable protection. Here shows the 360-degree panorama taken by our system and a photograph showing the lunar rover safely descended onto the surface of the Moon. Our contribution to Chang'e missions has attracted wide media coverage locally and globally. The space qualification technology inherited from the GPS has led to the successful development of instruments for the recent China's first Mars mission. We have over 20 years of R&D experiences in space instruments and participated in many international space missions, such as Mars Squad Crawler for ESA's Mars Express mission in 2003, soil preparation system for the Sino-Russian Phobos Grunt mission in 2011. We shall continue to support our nation's future deep space explorations, as well as making Hong Kong a center of excellence in the region for space resource research that benefits mankind.